Hello, 7th graders. I am flying to California right now, but I didn't want you to go without a review session. You've got a test coming up on Friday. I want you to be prepared. I want you to be able to demonstrate all the great stuff that you've learned, and you've learned a lot. And I've seen some pretty good work. So now it's time to show what you know. All right? Gave you the review sheet yesterday. Okay? Let's go over what's on the review sheet one by one. All right, we're going to break this video up into two. All right, if we're in the morning class, you'll see one video, take a 5-minute break, see the other video. If you're in the afternoon class, we'll do one video today, one video tomorrow after your field trip, and then the test on Friday. Okay, all right, so the first video that we watched, what are the basics of motion? All right, 3 big ideas that you're going to see here. All right. Vector quantities versus scalar quantities. Vector quantities are measurements that have both magnitude and direction. They give us more information than something that has a number only. Scalar quantities are like a scale. They only give us a number. So things like distance, speed, those are scalar quantities. Time, okay? They don't have any direction to them. Vector quantities are like displacement, velocity, acceleration. When we get into it later, force. Those have both numbers and directions. So you want to look at the different vector and scalar quantities. Go back to that video. Okay? Difference between distance and displacement. This follows along that same theme. Distance right here is a scalar quantity. It's a measurement, it's a length. Okay, we measure distance in meters, but we don't mark direction with it. Displacement is the vector version of distance. Okay? Distance is the path that I follow. If you remember that picture from the book, the squiggly line. Okay? My distance can be any path between 2 points, but my displacement is a fixed distance with direction of a straight line between those 2 points. So displacement is a vector measurement of distance. Gives me magnitude and direction. All right. Last question from the video. Velocity. How is it calculated? All right. Our formula is displacement over time. My change in position, or my displacement, divided by my change in time. All right? We did this for the lab. We calculated the velocity of the cart as it was going down in 3 different instances. 3 books, 2 books, 1 book. All right? We took our final velocity minus our initial velocity. Remember that? Okay? And we divided that by our final time minus our initial time. So we get our change in displacement, change in position, divided by our change in time. It's that simple. Okay? That's going to be our average velocity. Cool? You can also calculate velocity from the slope of a line with distance versus time. Let me see if I can draw on here. So, oops, can I do my pen? I can't. Okay. So, in my distance versus time graph, okay, what you can do, oh, here we go. We can draw one really quick. Here we go. So, I've got displacement on the y-axis. I've got time on my x-axis. Cool. All right. And so, if, let's see, can I put a little text box? Let's do that. Bam. Distance. Where's my mouse? Can I make that float over? Wrap text in front. So I've got my distance over here, and I've got my, oops. There we go. Get another one. if I could grab it. There we go. Move that over here. Okay, displacement versus time. If I look at the slope of that line, put another one in here. If I look at this slope, if it's a positive slope, it's a positive velocity. And my change in y over my change in x, or my change in distance over my change in time, equals my velocity. If my velocity, my line is really steep, my slope is really steep, that means I have a high velocity. Distance is changing a lot with respect to time. If it is pretty shallow, let's see, grab it, there we go, then my velocity is slower. Okay, I'm gaining less distance with time. If it was flat, you'd see a slope of 0 means a velocity of 0. My displacement or my position isn't changing. Okay, so we have a formula to calculate velocity, change in displacement over change in time, or you can calculate it knowing your slope on the distance versus time graph. Cool? All right, let's move on. Get rid of these. All this can be found in the video. All right. There we go. Got rid of that. No, didn't get rid of it all. I don't have my little mouse with me. Delete. Delete. There we go. All right. The reading was similar. Okay, focused on distance and displacement. This is section 1, right, in chapter 11. We talked about choosing a frame of reference, all right? In physics, we like to have a coordinate system. We want to measure from some fixed place. And when we measure, we want to do that with two objects that aren't moving relative to each other, all right? Now, we're all moving relative to something. So you need to pick our points of reference so we know what we're measuring and how we're moving, okay? How do you measure distance? You measure distance in meters. That's our standard unit, okay? And you follow the path that the object takes. Displacement is different, okay? Displacement is that straight line between 2 points. Has a number, a magnitude, and a direction. That's a little arrow that's on top, okay? Now, we can combine displacements, all right? If, say, I'm going 3 meters east, and then I go another meter east, how far have I been displaced? 4 meters to the east. I add up my displacements because they're vector quantities. I can also say I go 3 meters east and then 1 meter west. If they're on a straight line like that, I know my displacement is now 3 minus 1, which is 2 meters. 3 meters east, 1 meter west. My total displacement, my resultant displacement vector is 2 meters. Because they're going in opposite ways, one of them is negative. 3 meters east, 1 meter west, my resultant is 2 meters east. Okay. You can also do it not on a straight line. If you remember the riverboat problem from the book, I go 3 meters east, 1 meter north, and now I make a triangle. I connect those arrows end to end, okay, butt end to the point, and I make a triangle, and that's going to be my resultant displacement, okay? Are we going to do calculations like that? No, but you may have to do estimates and draw it out, okay? Vocabulary, frame of reference, relative motion, distance, displacement, resultant vector. We've just talked about those a lot. Make sure you use the Quizlet, okay, to quiz yourself. It's all the definitions straight from the book, okay? Video 2.2, we're talking velocity and acceleration, all right? You want to know what happens when velocity changes. Velocity can change either in the speed, okay, I can speed up, I can slow down, or in terms of my direction. I can maintain a constant speed but drive in a circle and constantly be accelerating, right? Acceleration is a change in velocity. How do I change my velocity? Either changing my speed or changing my direction, right? How do you calculate that acceleration? It's my change in velocity divided by my change in time. Just like we did in the lab, nothing new here. My final velocity minus my initial velocity divided by final time minus my initial time, all right? That's how we do the average acceleration. You don't need to calculate instantaneous acceleration, all right? It's mentioned in the book, but you need calculus to do that. I want you to know that it exists, but you're not going to be calculating any instantaneous acceleration. The video went into at what rate do objects fall, okay? This is called free fall. When an object accelerates due solely to gravity, its velocity is going to increase and increase and increase and increase. Okay? The velocity does not stay the same. It gets faster. The rate of acceleration is constant. On Earth, all objects in free fall accelerate at 9.8 meters per second squared. Okay? So it increases by approximately 10 meters a second every second. If you go back to the video, it shows. So the rock falls. After 1 second, it goes from 0 meters a second to 10 meters a second. In the second by 2 seconds after it started, it's going 20 meters a second. After 3 seconds, it's going 30 meters a second. After 4 seconds, 40 meters a second. So it keeps getting faster and faster and faster. Why? Because it's in free fall. Okay? So when I accelerate positively, I speed up. When I decelerate or have negative acceleration, I'm going to slow down. Cool? All right. Vocabulary. You need to know what acceleration is. We just defined it. What free fall is. Just did that. Constant acceleration is when the rate of change in my velocity is the same during each time period. Okay? Linear graphs is where the slope is a perfectly straight line. Nonlinear is where the slope is curved. Okay? On my distance versus time graph, accelerations are going to curve. Remember in the lab, you got that nice S curve to it. When I'm accelerating, I'm going to cover more distance with time, so that line curves. Okay? Once again, instantaneous acceleration is acceleration at a moment in time. We don't know how to calculate that yet. Hang on for high school. All right, we're done with half the review sheet. I'm going to take a break. Take a 5-minute break, stretch, wiggle your toes, itch your nose. Come on back when you're ready. Afternoon class, we'll do the second part tomorrow.